Hello everyone, I'm Deepak, a cloud solution architect here at Oracle OCI. Today I will be walking you through the process of how to run open source Nextflow pipelines on Oracle Cloud Infrastructure. Let's get started. Before we start the presentation and demo, I thought to clarify that this video is not about explaining Nextflow in detail, but to cover basic aspects and focus more on how to configure and run Nextflow on OCI's cloud infrastructure using HPC and GPUs. With that, let's understand what is Nextflow and why we need Nextflow. The rise of big data has made it increasingly necessary to be able to analyze and perform experiments on large datasets in a portable and reproducible manner. Now that parallelization and distributed computing are the best ways to tackle this challenge. But the tools commonly available to computational scientists often lack good support for these techniques, or they provide a model that fits poorly with the needs of computational scientists and often require knowledge of complex tools and APIs. And that's where Nextflow was created to address these challenges. And again, I'm not going to go too detailed into this diagram, but the whole idea of Nextflow is it's an orchestration engine for data pipelines. It's cloud agnostic. It uses containers so that it can become very, very portable and flexible. And if you look at all these boxes, it starts with simple Nextflow pipeline scripts, and then your data, you feed in the data samples, values, and then that computation is getting scheduled, executed on the high performance computing, either using CPUs, GPUs, and then eventually that containerization is to give you that flexibility and that reproducibility and that consistency between the environments. If you want to move from one from the other, like on-prem to cloud or cloud to on-prem, either way. So that's what Nextflow at very high level. Please pause the video if you want to read here in more details. Moving on, what is Nextflow pipeline, as we were just talking on the earlier slide? So this is a very basic, simple example of a Nextflow pipeline. As you see here on your left side, it's you provide the data file, as I was talking about earlier. Then these are the two simple processes, and then there is this workflow trying to put these processes together. And sometimes an input, the output from one process can be an input to the next process. So it can get very complex, but this is a very simple attempt to explain what does it Nextflow pipeline looks like. Now, if we look at it, and that's what our goal today is, to go and see how Nextflow looks like on OCI. And this is a very basic architecture I'm trying to explain here. Is as a researcher, you're trying to get into your cluster and get into that login node and the controller node, and then eventually develops or pull the Nextflow pipelines from your GitHub or any repository of your choice. After that, you will be configuring that Nextflow pipeline and where the data files are located, and what pipeline to use, and so on and so forth, and help everything with the Slurm scheduling, the jobs on your cluster's compute nodes powered with CPUs and GPUs as well, depending on the pipeline and the requirements and the design. And this is where OCI's, as you can see here, performance storage with either raster file system or object storage can be leveraged to keep that data wherever your cluster is. So that was a very high level overview of what is Nextflow and what does it look like on OCI. And that's where we're gonna get into a quick demo how it all looks like. All right, so if you look at here, for this particular exercise, I have been using our own stack, which is free. It's basically a Terraform-based resource manager as a stack provided to you, so that way you don't have to stitch together all the networking or any other IAM and required components. It's all put together for you so that you can simply launch this stack, start filling out the details. And once the stack is ready, then you select your configurations, give it a name, then put your SSH keys, so on and so forth. But just to save some time, I will walk you through a stack which I have already created for today's exercise. And this is my Nextflow cluster, which was created through that stack. And if you look at this particular cluster, and if I can show you really quickly, if I can edit stack, go on to next, yeah, you see my SSH keys has been provided. Then there is a head node, which is also called as controller node in Slurm. And then, there is the compute node, and this is what we will be using in today's video is using bare metal GPU node. That's where, all the action is going to happen. So likewise, you fill up all the details and, yada, yada, and then your cluster is ready. Now, if we have to get started with Nextflow, first, let me just walk you through that how you can install Nextflow on OCI. So we have a pipeline, sorry, an Ansible playbook which is created, and you can see simply here what does it do is it will install Java, then it will download and install Nextflow. It will also get Singularity, which is nothing but something like Docker, like a container engine. Singularity also helps with something similar on Linux systems. And then finally and if you want me to see how to install an Ansible, Nextflow using Ansible playbook, it's simply gonna take a couple of minutes depending on your configurations and what you want to add, but this should get you started easily installing Nextflow. So I'll wait for a moment while it's installing. And this is where we can see that Nextflow has already been installed using Ansible playbook. Now, just to recap, Nextflow installation with Ansible playbook, we have provided that, and then here's a quick recap of what it is doing. So basically, we are asking that there are two different hosts. One is my controller node, and this is my actual compute node where all the action will be happening. But it's essentially it's kind of the task for Ansible playbook that go install it on both the hosts. That's it. Now let's look at what's the pipelines we will be running. Let me get back to my environment where I will be showing you. So for this particular demonstration, we will be running two different pipelines. One is the RNA sequence and the which runs using CPUs, and then there is another one which uses Parabricks or built with Parabricks called like Germline, and that will be running on fully on GPUs. So let me just walk you through the directory here. So if we go back to what we discussed earlier, that Nextflow has its own data we have to provide, then we have to provide some configuration. So if I can show you what's the configuration looks like for this particular pipeline, I can pick up one of these files here. So since I will be using Singularity for this execution, let me just show you what's the configuration looks like. So here it's very simple. We have given the profile that use Singularity, and then here is the actual process. That's where we are providing all the details like what's the executor, what's the queue, are we going to use any GPUs? Of course, for this particular pipeline, which is not compatible to run on GPUs, it will skip that, but this is how you provide your configurations. And if we look at the data, I can show you, like if I can print this file, since we will be using Singularity. So this is just to a simple shell script rather than typing the command all the time. We just have created this simple shell script, and this is where you can see that we are providing a configuration file. Then we are providing. Sorry, I think I showed you the wrong configuration file, but let me just show you what's this configuration file looks like. nextflow.config. Yeah, and this is even the smaller version where we just are like trying to provide what's the container we will be using, what are the options, and if you look at here, this shell script, we are using that configuration file. Then for some of the test data which is coming from the test configuration file, and there is another file where we will be also using some data from the straight from the internet. And if I can show you that file as well, this is how we have that data coming in, which is required for RNA sequencing pipeline. With that, I guess let's run this using Singularity. This pipeline is going to take a little bit of a time. And as you can see here, since this pipeline was designed to run using only CPUs, you can see like, a CPU activity going up and down, depending on what parts of the pipeline it will execute. So eventually, it will start scheduling all those tasks. You can see all that parallelism going on. While this is all running, I'll just pause the video. It's going to take 3-4 minutes or so. All right. As we see, this pipeline has finally completed its execution successfully. You can see it's printing some stats like the duration, how much CPU hours. So it shows like 1.2 hours because it was running a lot of these different steps and then the tasks inside it sequentially, and that's why it shows. And it doesn't show any GPUs here or regardless because the GPUs was not part of this particular pipeline. And if I can just show you real quick, every time you run your pipeline, it keeps on creating log files. So this is the latest log file, and as we provided, like, yeah, send my results or save my output reports into this results file. And that's where if we really quickly try to look at the output. So this is the command, or this is the pipeline we ran, like RNA sequence, and these were the outputs. So it shows you like, how that execution was completed, how the CPU was exactly used for different processes here, and then physical memory, execution time, whatsoever, and all the tasks and all the details are printed in this report. Likewise, it also creates some sort of diagram. It's very hard to see here because there are way too many processes interconnected. So, but the idea is, it prints the report with a summary, and then it also gives you the flow of flow of the execution of that pipeline. On a similar line, let's quickly run on another pipeline, which is Parabricks based. So I'm gonna go into that pipeline folder. Basically, this particular pipeline or this particular example from NVIDIA Parabricks has two different pipelines. One is FQ2BAM and Germline. I've already executed them a couple of times. I'll just execute one of those, which is Germline. And the process is still the same. You have the config file, then you have to have a data and just have a shell script where I'm gonna run this pipeline. All right, now you can see here this particular pipeline will use CPU a little bit in the beginning, but as you see, since this is gonna use GPUs, because it is designed to run on GPUs, you can see the GPU utilization is going up, which wasn't the case in the previous pipeline, and you can see how the WAT, like how the maximum throughput from the GPU is helping run this pipeline, and it's gonna be really faster than the earlier pipeline. You see that one of the process in this pipeline has already been finished, which is deep variant. And then it's just now trying to finish this haplotype color. And as you can see, everything is running only on GPUs. It doesn't really use CPUs. It shows the CPU percentage here, but all the heavy lifting is happening on GPUs here. And this pipeline is gonna finish in a few moments. Right, we just see that this pipeline has been already finished, and remember I was mentioning that it shows the CPU percentage, but in reality, the stat shows here the CPU hours were like really few seconds of CPU hours, while Slurm was trying to schedule the jobs on GPUs, and then unfortunately it doesn't show the GPU stats here. Even if we try to see the report here, the one we just ran for germline, it doesn't show any CPU stats. It shows CPU stats, IO a little bit, tasks, but it doesn't show any GPUs because I guess it's not yet designed within Nextflow community reports. But if I can go back to those DAG reports, which was like very lengthy for the RNA sequence, this one is a very simple pipeline, which has really two different processes, haplotype caller and deep variant, and this was one of the ones I already executed. So that brings us towards the end of this particular demo and the presentation. And if I can show you, there are some resources and references we are providing with this particular presentation. And then there is also a GitHub repo which will be updated with more details, but it is just how can you run this all on OCI with this simple architecture using Slurm and Docker or Singularity and OCI's high performance compute. Thank you so much for your time. We are here to help you. Please, reach out if you have any questions. Thank you.